Hello and welcome to the latest in our webinar series of digital construction techniques. This is all about building surveying technologies. And this is the latest in a series of webinars. We've covered quite a lot in the previous ones, from different types of laser scanning, digital twins, drones, machine control. So all of them are available to watch on YouTube on demand. So you can watch them as and when you need them. And I think just a sort of quick word on this. You know, productivity is one of the biggest challenges in the UK at the moment, and something that hasn't really moved in the last decade, particularly in construction. And you know, we at SurveyTech really feel that technology is the way to help improve that. And so we're very lucky that we've got some great speakers to share their knowledge and interest with us today. So going in order of speaking, we have Kate Hintz, Carl Skelson, and Shirley Underwood. Now, Kate, you're going to be speaking to us about reality capture and laser scanning. Can you tell us how you got into that?
Yeah, so my previous company, which was Syed Group, I was part of the Syed Studios, and I started off as a CAD technician. And then throughout the last 6.5 years, I learned 3D laser scanning, first on the Faro, and then moving over to Leica. And then we also taught Revit and 3D building modeling, and it's sort of developed from there, really.
Well, thanks for joining us today and sharing all your experience. Kyle, you initially were a qualified electrician, and then you got into thermography. Is that right?
Yeah, that's correct. So qualified as an electrician quite some years ago, and from that got into thermography and have been a thermographer for the past 6 years, and recently qualified as Category 2 as well.
Yeah, that's great. And obviously, I think a lot of people aren't even aware that thermography is used in electric. So I'm looking forward to getting into that with your presentation. Um,
Yeah.
and finally, we have Shirley Underwood, who's Sales Director EMEA region for Screening Eagle Technologies, and they have an absolutely wide range of non-destructive testing equipment available. I think Shirley, you're going to touch on some of those non-destructive techniques today. Can you tell us about how you got into it?
Well, Matt, actually, I'm a qualified accountant, and I didn't really like it in the end, so I moved into engineering. So the good news is that it's only taken me like 13 years now to understand about non-destructive testing. But now with the amazing software we provide, you can understand more in just a couple of like months. So it'll be interesting to show you some applications and what the products can do to provide sustainability really for like any refurbishments that you may need to do in the future.
Yeah, I think that's an important point. You know, qualified accountants or random guys with history degrees like me can actually understand your technology and how to use it, and that's been a real step change from historically. Things like GPR were extremely confusing.
Right.
But yeah, again, I don't want to get into it, and we'll leave it to your presentation. But first, we're going to start off with Kate Hintz. So, Kate, I'm going to make you the presenter now,
Perfect. Thank you.
and then you can get into your presentation all about laser scanning. So,
Thank you.
thanks, Kate.
So I'm going to, hopefully you can all see that. So I'm going to talk to you about surveying buildings. So just to give you a bit of background rather than diving straight into a couple of different projects. So to give you a bit of background, I started at Syed Group. So Syed Group actually started as a construction company and really valued the accuracy in design and build. And there was a real kind of natural progression into the 3D scanning world because manual measurements often fall down when it comes to complicated, intricate details. So 3D laser scanning, just to kind of give you a bit of an overview, we can capture 1 million points per second with an average accuracy of plus or minus 3 mil. The great thing is with SciAD, we were actually located in Oxford, and as part of that, we were surrounded by cultural heritage, allowing for surveying historical buildings. Now, I'm actually going to probably talk more about historical buildings than the other projects we worked on, just because of the interest of them. But we also did a variety of different projects, from boats all the way through to commercial units. So the great thing is with scanning for heritage is actually, you can scan throughout various stages of the REBA stages or a project, either from the beginning or all the way at the end. But the great thing is with scanning is actually it allows us to go into a variety of different elements as well. So at SciAD Group, we transform that 2D scan data into technical 2D drawings and 3D building models. So just to talk through a couple of different projects, Oxford Botanic Gardens, University College Oxford, Keble College in Oxford, Oxford Castle as well, and Blenheim Palace. Now the last two are actually the two that I want to talk about and focus on today. So to start with, we're just going to talk about the process that we took for Blenheim Palace. So initially, we started our collaboration with Blenheim and actually Rebellion Film Studios, which is a game development company, for their Churchill exhibition promotion video. So initially we just scanned a few rooms and the external of the palace. This actually then we delved deeper as the client at Blenheim really understood the value of what we could get from this scan data. So we then scanned all the internal and external features of the palace spanning the 28,000 metre squared estate. This took about 3 to 4 weeks intermittently. There was some filming going on, so we had to work around that. We used the Leica RTC 360, which I'll touch on in this webinar as well, and Cyclone Core and Cyclone 360 to register the data. So the data that was gathered was really valuable for multiple purposes, whether that was facilities management or the upcoming restoration of the palace. So if you're aware with Blenheim, there are ongoing works. The data was then captured on site. So as you can see, there's a photo of us on site, and then the registration. Now, if you're unfamiliar with what registration is, we take all those scan locations and register them together to complete a 3D point cloud. This data was then used to create a 3D building model, which you can see in the bottom corner here, and that's actually been run through a visualization software. Now, the 3D model was really crucial for understanding the palace in detail. So it was used for the preservation and facilities management, and we took 2D drawings, so floor plans and elevations, to understand the palace in more detail. Now, to start off with, what's been great about this project is we just initially did the full external to the highest level of detail, and then the floor plans were just done to LOD3, and that's just allowed the client to then get an understanding of the kind of overall space and size of the building. But the nice thing is with Point Cloud is you can go back at any point and we can add more and more detail to that building model. So just to talk about the Leica RTC 360. So we initially were working with Faro, and I'll talk about that in this webinar as well. But the great thing about the Leica RTC is it's highly portable and automated design. It's paired with the Field 360 app, which you can see in the photo on the left-hand side. And this really facilitates seamless 3D scanning. So it automatically records your movement, and it allows for pre-registration of scans without any manual intervention. So with all the features activated, so that includes the high resolution scanning, the photos, the 2 paths of removing moving objects, and the onboarding pre-registration, it takes about 4 minutes and 21 seconds, which is amazing that in less than 5 minutes you can capture a wealth of information. Now, like I said before, this data was then captured, processed and registered, and then can be given to either the client or the BIM team or other stakeholders involved within the project. So because we were using the Autodesk package, we were then sharing this data through Recap, which is an Autodesk package, and an LGS format. Now, LGS is great when it's powered by Jetstream, and the great thing about it is it really allows flexibility and access of all the project data, so that you can walk around the points, the imagery, you can take measurements. And for us as building modelers, or even the client, if you've never been to site and you don't quite understand what's going on, you can dive deeper into that point cloud and those photos. So throughout all of our projects, we integrated 3D scanning and visualization as a crucial part for documenting heritage sites and all of our projects, establishing a point in time archive for recording, for presentation, research, education, protection, and renovation. Now, these 3D technologies are becoming easier to access, and it allows people to really understand their building from all the different angles and even access buildings that you may never get to, as the general public, for example. So the next project I want to talk about is actually Oxford Castle. Now, this particular project was very interesting for me because it was one of the first projects that I really got involved with, especially, as it's if you don't know Oxford Castle, it's quite a well-known building within Oxford. And we initially started the kind of collaboration with Oxford Castle back in 2019. Now, the castle is 800 years old, and it was a 12th century prison. Now, as you can understand, the walls are not linear, and there was you could really understand the kind of history within the building just from looking at it. So what we did is we went on site and we 3D scanned all the structural elements, which really then allowed the client and the restoration team to understand what was going on within the castle. And from that, we then produced a 3D building model and 2D drawings. Now, this was really, really helpful for those non-linear walls, as it aided in cost analysis, project planning, and that conflict of design as well. And so this actually then led on to us scanning the Debtors Tower, which you can see the circle building in the top right-hand picture, and the mound as well. So for this project, which was actually carried out before we purchased the Leica RTC 360, we used the Faro X130. Now, despite it having a built-in camera, the Faro X130 was really powerful with its precision in capturing data and really helped us for those non-linear, complicated walls. So actually, as part of this, we actually used a fisheye lens, and we took 4 photos around each side of the tripod and stitched them together. Now, those photos were then aligned with the 3D point cloud to add color, and also for us to understand more about the palette, about the castle in detail. Now, unlike the Leica RTC, there were no no automated tracking. It was only manual recording, which was then tracking those locations. The next thing that makes this project very interesting is actually we scanned the mound, and the reason we scanned the mound is because they believed there was some movement happening, which was very important for the preservation and maintenance of the mound. So we scanned it across 2 distinct seasons, and this really allowed us to take the 2 scans across and align them and understand what was going on. So as you can see in that picture, it's not 100% clear, but you can see that there is actually there was movement, and it was only 6 months apart, and we could take dimensions and they could see where the biggest movement was happening, and it's allowed them to really maintain that mound. So lastly, I just want to sort of touch on the utilization of scan data. So the first thing is drawing. So you've got whether it's planning or design or construction. Once you've got that 3D point cloud, you can take it into a 3D building model and your 2D drawings, and that can be used throughout the kind of lead of a project. You've then got the accessibility. So those digital deliverables facilitate that seamless access and data sharing across clients, subcontractors, designers, whoever may be involved with the project. And that's particularly beneficial for ongoing design and construction projects, as it allows for collaboration, enabling real-time decision making, and reducing costs. You've then got that capturing reality. So all of our projects, we were working with a 3D point cloud and then taking them through to 2D drawings on 3D models. And this was really helpful because, like I say, having that preservation and that kind of point in time was really important for the next stages of those projects. And lastly is explore. So the fun side of point cloud, it allows us to utilize things like VR, renders, videos, walkthroughs, and actually allows clients to be immersed into their asset. And that's sort of a bit of a brief overview of some of the projects that we've worked on, and a little bit of an overview of laser scanning. So thank you very much.
Thanks so much, Kate. And so I neglected to mention that we have a questions box, and people can put in a question as they come in, and so please do. We'll come back to them at the end. We've already had one, not a question, more of an observation. Great presentation, well delivered, Kate.
Thank you.
I'll put that in now, but we'll absolutely come back to as many questions as we can after the presentation. So we're going to crack on now, and Kyle is going to be telling us all about thermography and the many exciting uses it can be put to. Thanks, Kyle. I'm just going to make you a presenter because I was too busy looking at the questions there. There we go.
Bear with me. That will come up. Can you see my screen?
That's all up. Yeah, thanks a lot.
Lovely. So what I'm going to talk about today is the many uses of thermography and what actually makes it so useful. A lot of people have some preconceived notions of what thermography is, mainly due to watching videos, watching films, and believing it can see through walls or do lots of other things that it can't quite do. So today I'm going to go over sort of a brief introduction to it, what you can and can't do, and why it's so useful. So first of all, it's non-contact. It keeps the users completely out of danger and doesn't affect or impede the target that you're actually trying to study or establish. Because of this, comparison between the areas of the target is possible, and it allows you to capture very fast changes within heat or changes within the object that you're observing. Now, there is actually a definition of thermography and how it's defined by the ITC, and it's defined as the process and acquisition and analysis of thermal information from non-contact thermal imaging devices. And that's a big point with thermography. It's non-contact, so it allows us to not destroy anything and get some of the information we need. Now, every object that has a temperature above minus 273 degrees C gives off some form of thermal energy. And this is actually given off as radiation. This is what our camera actually picks up and allows us to see. It's actually invisible to the human eye, so it operates on a completely different wavelength to what we're used to. Now, heat is defined as the thermal energy that's exchanged between objects having different temperatures. Therefore, if something has the same temperature, no analysis is possible. So if we're looking at a wall in a house and it has a homogeneous sort of temperature across, we will see nothing. However, if there's moisture, if there's an air pocket, this can be seen as there will be a difference in the density and a difference in the heat loss. With thermography, it's visualized as red, blue, white. And what happens is we actually use colors to represent the different scales on the actual thermography, on the actual scale. Some people have a misconception that with thermography, if you look at it and it's blue, it's cold, and if it's red, it's hot. Unfortunately, that's not the case. The way thermography works is it's relative to its environment. So if we look at the image on the screen here, we can actually see the coldest parts of the image are defined as blue and the hottest parts are defined as white. However, looking at the scale on the right-hand side, we can see that the coldest parts on this image are actually above 100 degrees, which is far from cold. The reason this is we're actually looking at a fire and a furnace. So these parts are relatively cold compared to the fire itself. And this is something we do need to be aware of. The difference with thermography versus visible light, as how we see, we need some form of light source. We need the light source to bounce off of the object for that to then reflect into our eyes. Whereas with thermography, it is completely the opposite. No visible light is required, and all is required is some form of heat radiation that is given off by the object. As I spoke about previously, anything above minus 273 degrees C will give off some thermal energy, so it will be able to be seen. This is why during sort of police programs, you'll see them chasing a criminal at night and using thermal imaging, because regardless of the circumstances or light, they can be seen. Just a sort of a quick visualization as to how thermal can help us very quickly. We've got 2 glasses of water here. One has warm water in it and one has cold. With our eyes, we have no idea. We'd have to do some further investigation. However, briefly looking at it through a thermal camera instantly paints a different picture. We can quite clearly see the difference between the two and the temperatures, and this is what thermography allows you to do. So there is a wide range of applications in regards to thermography, whether it's external buildings, electrical internally, or internal of buildings. From the externals, you can calculate heat loss. You can see thermal bridging between buildings. With electrical, you can actually study fuse boards and notice any loose connections, any overloading in the system. And with internal, you're actually able to notice and locate if you've got any moisture ingress, any condensation built up, as well as looking for any faults within your electrical underfloor heating. Now, that is really just a quick sort of brief overview on thermography and the actual uses you can have for it. At SurveyTech, we provide the full sort of service, whether it be providing you with the scanning, providing you with some training on it. We're happy to provide you with it all.
Thanks, Carl. That's a real whistle-stop tour. And you know, I think thermal really is one tool in the sort of non-destructive testing arsenal, yeah. And obviously allows you to diagnose some building pathology, and I think that neatly brings us on to another champion of non-destructive testing. So Shirley's going to show us even more techniques to allow us to sort of understand what lies beneath. So Shirley, I'll let you take it away. I like your background. You've got all of the kit behind you.
Yes, I do. Thanks, Matt. Let me. Oh, can you? Yeah, can you see my screen?
Oh, yeah, but right. We're looking at GoToWebinar now. Yeah, there we go.
All right. So I'm glad I've got a bit more time because strap yourself in. So I work for a company called Screen and Eagle Technologies. We are a manufacturer of non-destructive testing instruments. Most of our customers recognize us as ProSec. We've been manufacturing for 70 years. This is our 70th birthday. But really, the power that the thing that has changed mostly with Screen and Eagle is the software. We build technology and power it with software to drive digitization, productivity for safety, quality and longevity of our built world. We are global, and so you can find us pretty much everywhere in the world. So this is a nice image of the products we manufacture and what they can be used for with our engineers. So generally, if I can split this into two, the left-hand side is the products that would be used mostly for structural integrity, and on the right, the products that are used to demonstrate the imaging of what lies beneath the surface. So like you said, it's come at the right time. So we can see inside of concrete, which is very, very beneficial if you have defects or if you're trying to find objects or understand whether there's any corrosion activity like within the concrete itself. Yeah, so if we talk about structural integrity here, mainly when you want to understand about compressive strength, you know, how durable is the concrete, you know, can it last another 50 years? Mainly people take cores, but it's expensive, it's destructive, as you can see, and it's limited in scope. You'd have to take a lot of cores to understand about this concrete. So if you combine it with NDT, this leads to improved estimates, and it allows you to comprehensively assess the entire test region. So all of this wall if you wanted to. So we manufacture a product called the Schmidt Hammer. It's been around for 70 years, but now we've become more digital, and we combine it now with like an iOS app or an Android app. You take 9 tests, and then on the right hand side here it correlates it, and you can calculate the compressive strength, and in one more tap you can then create your report. So we become a lot more productive and effective And on top of that, it's also about cost nowadays. People want to spend less money and do things faster. So in an area of say 180 cubic meters, generally you'd have to take a minimum of 12 cores according to standard. But if you use it with the Schmidt hammer, you'd only take 3 cores, and then your saving would be 1800. So we also made it more affordable, and you can make more money from that. This is another example of on a real site, a real story. So this is obviously a structure that's where a company has provided a precast element, in this case a beam, and when it's arrived, you can see a big cold joint, a big crack that you can see from the surface. Now, generally you'd have to take cores to understand, is it a problem or not. So we have some tools. This is an ultrasonic tool whereby you can use ultrasound to travel through the concrete to understand the velocity, and then the velocity here can then be graded into different qualities or classifications of concrete. So as you can see here, the engineers went up and they did the test with the pundit, and lo and behold, most of the results came back green. So it was good news for the precast, and it was good news for the structure or the asset company, because they could continue with their tests. And so this original, the pundit UPV instrument is a little bit old-fashioned now, because it has cables, and you have to generally go around the structure. If this is a wall, you'd have to get to the other side. So in recent years, we've manufactured a new product called the PD8050, where you only need one side to test and to travel through the concrete to obtain the same results. So it's much faster. So I'm going to go into the concrete imaging side of our product line, because it's really interesting and a bit kind of sexier in terms of what you can receive in terms of the software. So this is a Pundit Array, that last instrument I was talking about. This instrument you can use from one side. So if you're testing a wall and you want to understand where there's any defects internally, like a crack or a void, or some type of void inside, you can test from the surface, and then you can clearly see any defects internally. So we can see through walls. And if you want that in 3D, we also have that directly on the iPads. So the way that this works is that it uses ultrasound, and it has 8 channels. So when you trigger the test, each channel transmits the sound in turn and captures 56 shots all at once. So the complete cycle is then completed in milliseconds, and the individual then can see a B-scan image. So what you can then see internally is if the concrete is clean or not, so no defects inside. So when you've got a nice blue setting, there's no defects, and where the red line, so this is, we call it the back wall echo is the other side, and you can clearly see the thickness of this element. So I suppose that for interpretation, the most important thing I'd like to leave you with is for ultrasound. What happens is that with ultrasound, you can travel through metal. So if you have rebars, it will travel through rebars. But if you have a defect that's voided, 100% of the reflection will come back, and you can clearly see that at as a B-scan image. So this is just like a couple of examples. So you would travel along with the Pundit Array. It would then find your rebars for you, so it can still travel through. And then when it finds a defect, it completely reflects, comes back. And then the most important thing is that you can understand that it's a void of some sort. So here it could be honeycombing. And then you can calculate where that void is, which is the one thing that's important to understand. And also, is it just a little? Is it like a tennis ball? Is it like a football size? So then you can understand the magnitude of the problem if you have the problem, and then you'd be able to repair that easier than if you had no idea of what it was inside or where it was. So very good for voids and honeycombs. This is a nice just little video to understand also that we use AR tags that we can capture using the background. So in this instance then, we've done a test and we want to figure out, is there any pipes within this concrete? And lo and behold, there is, and there it is in 3D. So the software has really made the visibility of, it's just much easier to understand what's going on inside. Then the big, well, I suppose the instrument of the moment is GPR. I'm sure there's many of you that use GPR. Historically, it is an instrument that understands, well, that visualizes what's happening below the surface. So especially in archaeology, if you're trying to find objects internally, so you're using its utility world, it's used to find like relics, voids, like anything underground. That's where you use GPR, but it's also very popular in the concrete world, mainly, I suppose, to understand where the rebars are, so that you can avoid hitting steel if you're doing coring, for instance. But it's becoming a lot more clever. So we at Screen & Eagle had a lot of demand to produce our own GPR. So we did, and that was like 5 years ago. And since 5 years ago, we now have 3 different types of GPR that you can use for different inspection types. So here, if you have like a small column, you can use like a mini version. We have like a general antenna, which kind of can get to depths of 150 centimeters, and then an array, which makes the job much faster. So here, what is ground penetrating radar? So you have like an antenna. The antenna is then moved along, and the encoder captures the distance it travels towards the defect, and then it will draw around the defect. So it's time of flight, and it's electromagnetic waves or radar. So then you can tell whether whether the objects are either round or flat. Metal targets have 100% reflection, and AR-40 a little bit opposite of what the Pundit does. People generally ask, how deep can you get GPR? It all depends on the antenna that you're using. And it's also very sensitive to the change of material. So effectively, the more moisture the substrate has, the less it will travel through, and so the shallower it will be. Typically, GPR is a pulse radar, so effectively you have to have different frequencies to travel different depths. So the lower the frequency, the deeper it can travel. The higher frequency, the better it is to see objects and detail at the surface. So when we brought ours out, we had to do something different. So what we use is step frequency. And what that does is that we have a wider range, a wider bandwidth. So talking technical, basically, we have a lower frequency and a high frequency all in one, so you don't have to separate them or use different antennas. And it means that you can travel down to 1.5 meters or see objects very close to the surface. So anyway, that's all technical stuff out of the way. As I said at the beginning, we build tech and we pair it with software. So on the iPads, just after you finish your test, you can see the traditional hyperbola. So these are all rebars. So you can just swipe through it, and then you can see the rebars itself already processed. We call this migrated view. And then you've also got a time slice, which you can pull down to peel the onion to understand where things are, where objects are at different depths. And then we also have like really cool 3D imaging, so you can view it in 3D, something very popular nowadays. And you can also export it into CAD if you wish. So again, some more visuals. So this is, like I said, the 3D imaging. This is just, you can do also huge areas to find the rebars at different thicknesses. So that's a very good way of viewing what's going on inside the concrete. This is a nice kind of example I can give you. This is a jetty over in Asia. What they did was they wanted to find out underneath what's happening. So obviously, being on water, it's very difficult to get to the underside of this road. So we used GPR to figure out what was happening underneath, and to see if there was any corrosion. And lo and behold, there was. We did like a line scan here, so you're just traveling along You can see all the rebars here, and then you get to an area where the reflections are very messy due to the fact there's lots of air on the surface, just where the rebar start to corrode and break up and spoil the concrete. And then someone had a look underneath, and lo and behold, there's your corroded concrete. So not only is it used for just detecting rebar, but nowadays also with augmented artificial intelligence, we're able also to provide condition assessment with the GPR. Another example would be here, Knightsbridge, that I guess Kate would like to scan. This is a masonry bridge, figuring out whether you can find a void inside of stone. So it's also used for many other types of materials, not just concrete. And actually, this is a nice video of again an area scan that was made by Rory Foley over in Cobra Concrete in the States, trying to understand whether GPR, our instrument, could locate heating systems. So then you can see at 0.4 of an inch, you had like the nice water pipes heating system in there. So again, very flexible products that can be used for various different types of assessments. This is a post-tension slab. Again, another video to show there's a rebar. I'm traveling through, peeling the onion, and there's my post-tension ducts and the concrete slab in a Singapore building office. And then last but not least, it's just augmented reality can be used with the different types of testing that you do, and directly onto the surface, so you can see if it's spaced like you can see right on the surface where your rebars are. With GPR, we have cover instruments, so rebar locators to see like where the lower concrete is captured, and then we have also like the PD-T50 for the ultrasound to understand where if there is any void, and also to understand about the velocity. The higher velocity means like the better quality of concrete. So I guess that's it for me, Matt. I'm going over my 10 minutes.
So. No, thank you, Shirley. There was a lot there. And yeah, I should also mention that we're going to be putting these up on YouTube if people want to refer back, because there was a lot of information there. I think.
Yeah, definitely.
I think it could be a good resource if you're thinking about structural investigation and what tool might be the best one. That was a really good overview. So thanks a lot, Shirley. I should also mention Shirley and I saw a lecture from a German academic who had taken one of her bits of kit to the Great Pyramids at Giza, and had used the ultrasound to find a previously unknown hidden chamber, which was very, very exciting. So yeah, it's amazing what you can find once you start looking. But we're just going to move to the question segment before we run out of time. So the first one has come in from Callum, and it's to Kate, and it's following on from where you've monitored movement in the mound with laser scanning. Have you ever done a similar scan to monitor structural movement? Could it be an alternative to traditional crack monitors?
Yes. So we've actually not really done it necessarily through SciAD previously, but we have done scans over a period of time, and then we've compared that scan data. And it's definitely the way that scanning is going to go. Like there's a lot more kind of inquiries that come through for scanning and monitoring, but I think sort of as Shirley's touched on, actually monitoring building, there's a lot more than just laser scanning, and actually another way that you could do it as well is through photogrammetry, and that's something, if you merge photogrammetry and the scan data together, actually it gives you a world of like a whole new world, especially of kind of cracks within buildings, and I think there's a lot more to it. And I think laser scanning is a great foundation for monitoring, but actually adding all the other technology into it, you really can develop the way that you can monitor buildings.
Yeah, I think that's probably a very good message. The digital twin is something that gets talked about a lot, but actually the combination of these two technologies, if you create a full 3D digital model and you're
Yeah,
also able to overlay what's underneath, that's a very useful digital twin because it's bringing you more information than you can go just by inspecting it. And
exactly.
Shirley, you've also got an inspection software where you can do some 3D capture and then put your scans into it. Is that right?
So behind me here we have inspection software called Inspect. So it captures all the data in one location, and we have some AI functionality where you can just scan the crack itself, and then it draws it out for you, and then you can do that over time and then see if there's any movement there. So it's at the initial stages, but over time we'll capture more and more and more cracks, and then eventually it will, with time, again, we need a bit more time to develop this, but you'll be able then to see the changes, the crack measurements themselves. So yeah.
And I think I should also mention we previously did a webinar on structural health monitoring where we had someone from Move Solutions discussing their remote sensors. And again, that's another technology that can be combined really well with having a full 3D model, using the data from what we know about the structure, and then also having remote monitors as well, so that you've got a sort of live update of the health of the structure that's informed by what we know of both the exterior and interior. So that's all on that webinar anyway. Next question is from Mohammed, who says to Shirley, it's like a CAT scan for structures. How portable is the device used? Well, very portable. The smallest one fits in the palm of your hand.
Yeah, actually, Matt's done a very nice video you could watch also on his website recently with the GPRs. So
Yes,
they're
that's a
super
good
light.
point. Thanks for the shout out. Yeah, we've recently just done a GPR video exploring the whole range in about 2 minutes with no technical stuff. But another question from Callum. AI has been used in monitoring condition of rack concrete in NHS facilities. Have any of you successfully, in brackets, or unsuccessfully, utilized AI to help analyze the data you collect? I think AI is a really interesting topic that I'd probably like input from everyone about, really. So if we start with you, Kate, about AI and how either you're using it or could you think it could be used?
Yeah, I mean, from AI regarding Callum's question, personally, I haven't used it because it's not something that I was getting involved with. But AI is like you say, it's a very interesting subject, and I'm a little bit worried in some aspects of where it's going to go, especially as my passion for 3D is really the building modeling side of things from a point cloud, and it is a bit concerning of where, could AI take over my job role and effectively generate a building model from a point cloud without any sort of kind of human interaction. It could be possible, and I do see it going that way. I mean, just like everything, they're going to need humans to test it and check it, but it's definitely something that's where I see, especially that point cloud to, the scan to BIM. That's the way I think it's going to go.
And I think it's worth mentioning in the sort of Leica ecosystem, they have something called HXDR, which is quite
Yes.
AI powered, and it's a great sort of 3D visualization tool and digital twin that's getting a lot of push into it. So yeah, and there's also some functionality in softwares like LSS for AI object recognition, which I think will
Yeah.
become more and more important in scanning. And yeah, so but on the AI thing, Shirley, you've already touched a bit on this about the AI crack monitoring in spec software. Is there anything else that you think might be relevant to mention?
I mean, like AI, this learn and capture of AI, that function where you teach AI how to identify objects for you. So, for instance, in our GPR, where you have to figure out exactly where the rebars are, if there's any corrosion, where exactly it is. So we do use AI a lot, and using it more and more to identify from like the signal echoes where the points are directly on the screens themselves. So a little bit like Kate, I guess that over time, a lot of the interpretation will help, but AI will help us with interpretation. I mean, again, GPR is something that you need to understand very well, and these are like assistance tools, I'd say, because there's yeah, lots of materials are difficult as well. If you're trying to identify objects in soil, it's completely different to like concrete, for instance, and so you need to understand about materials. But AI is fundamentally, I think, making it more just help people use the instruments, right? To understand what's happening inside, because we need our buildings to. I'm going to go on now about sustainability and renovation, and the fact that we have all these guidelines from the government to reduce CO2 emissions, and so therefore buildings are an important part of that, and AI could help reduce that. So I think there's a lot more to come with AI, and we use it a lot, basically.
Yeah, I think obviously we're still at the start of a journey with AI and what it will end up doing, and it's very good at doing repeatable manual processes and learning from them, and that can mean that it will. I know Kate said she was worried that it might take some of the jobs out, but it also will create opportunities as well. So it's going to be really interesting to see what happens, and also how we can streamline processes. And I think it will help us to monitor buildings better if there's a sort of quicker response in terms of identifying issues through that process. Carl, have you got anything to add? I mean, obviously you're here to speak about thermography, but you've got actually quite a wider product portfolio at Survey Tech.
Following on from what Shirley was saying, I do actually believe AI will help very much so on the reporting side. Same as with thermography, depending on the object you're looking at, it has different emissivities. So AI understanding the difference between sort of brickwork, soil, plasterboard, those will sort of be the challenges. But writing the reports, the repeatable tasks, absolutely, it's going to save a lot of time in regards to that. But you'll always need that human element to physically capture the data to feed it into the AI.
There was just a short question for Kate about using you said you used a separate camera with one of your scanners. And they asked basically, could you use a high quality DSLR to get better textures and things with your digital twins? Is that something you've done before?
Yeah, so actually with the Faro X130, we were using a Nikon, actually. This was like 6 years ago now, 5-6 years ago. So obviously cameras have come on massively since then. So I think actually, yes, you could. And I've sort of touched on photogrammetry, but actually combining the photogrammetry, with the fisheye lens, for example, really could allow you to enhance your laser scan. I mean, for example, the Leica RTC 360, it has a 4K camera, but it's definitely not, we've tried testing it through, Leica are quite keen to keep hold of the photos. You can't get like cubed maps from it. But, actually, adding the scan data and the photogrammetry together could massively help enhance your scan data. We were really using the photos. We're probably just scratching the surface with the 360 photos, to be honest. We were using it really just to walk through the building to understand whether something's a column or a wardrobe. But actually, I feel like, yes, you could really enhance your scan data with photogrammetry, and it just depends on what the outcome is. And we were using the cameras just really to color the scan data and walk through it. But photogrammetry, I think, is really starting to ramp up, and I think there's going to be a massive use for it in the future.
Yeah, and I think it's worth flagging that there's closer collaboration with NVIDIA going on with the Leica scanning world, and that real 3D render, having really high quality images is great for it. If you're something we spoke about in a previous webinar was that Notre Dame is currently being rebuilt based on laser scan data, a lot of which was done for a video game.
Assassin's Creed, wasn't it?
Assassin's Creed, yeah, exactly. So it's amazing what the data can be used for once it's captured. And to some extent, the important thing is capturing it, but also sort of organizing it. And I think that's why Shirley's inspection software is so important, because it's one thing going out and doing the scanning, but actually documenting it and change over time is really important. And Kate, how do you sort of organize your scan data?
So for us, it was all based on levels, to be honest. So it was the external scan data and the internals, and then that was split levels. Just because we work everything off a staircase, so one central staircase is kind of our datum for a site, and that was kind of the easiest way, especially with some point cloud, especially Blenheim. We had to split Blenheim into basically the main palace and the two wings because it was so big. It's like 4 terabytes of data. So organizing that was a bit of a mission. But to be honest, I think the big thing with any organization is actually that communication, and actually making sure everyone was on the same page, understanding what the different, outcomes were going to be. So levels was a big thing for us. But actually, we were predominantly Leica, but the Cyclone 360 app, the registration software, that's still got a long way to go, but it's got a lot of kind of organization within it, with your maps and everything now. So I think having something clearly labeled, and we had a clear naming standard, all of that made a massive difference.
Yeah, I mean, data management might not be the sexiest topic of conversation, but I think it's really important. And Shirley, there's a heavy cloud-based element to all of the Screening Eagle portfolio, isn't there? I wonder if it's worth just sort of touching on that and how everything backs up after you do your scans.
Oh yeah. So there's all our instruments are used. They're all Wi-Fi connected. There's no cables. And then it's attached directly onto an iPad. And then as you finish your scans, it's saved and it goes directly onto clouds. So the beauty of that is that you can then capture the data anywhere in the world, and be able to analyze and also communicate with the tester, so that if they make a mistake or they tested the wrong column or whatever, you can talk them directly through inspect. You can take all the photographs. You can collect all the data, you can create checklists, you can then have all the information in one location. It's all then saved up, and then you can directly use that on Workspace, which is like an internet accessible location to view your information. And then like Kyle said also about reporting, the cool thing about Inspect is once all the information's in one location, is just moving things around a little bit, pressing a button, and then it just creates your report for you. And so therefore it then becomes a very valuable tool, and it's all backed up, right? So in 10 years time, when I've left the company and somebody else wants to come and do another test of that location, it's all saved. So all the documents, all the pictures, all the monitoring, all the data capture is recorded and there forever, which is something that in the BERT world is hard to find, because generally the drawings are not there anymore. Which is why we need also laser scanners, right, to create again. But yeah,
great work though, doesn't it? Rescanning things because they've all changed. But yeah, I think that's an important point. It's one thing going out and capturing, but you've got to organise the data and make it usable. So whether it's connecting it with different sensors or what, it's not just about capturing for no reason. It's about using that data. So I mean, Carl, you're across quite a few portfolios. Is there anything you'd like to add on that sort of thing, and how different techniques can be used together?
Honestly, no. So Kate and sort of Shirley covered it really well. We'll add that sort of AI is coming to the Matterport side of things as well. So AI will be sort of taking over a lot of meaningless jobs, but hopefully will still be needed.
Yeah, there's some great property reporting stuff that's come through on Matterport, where it creates a floor plan for you for free through AI. And I think using those digital twins, hopefully to tie into some of our other tech, and that, without it turning into a sales pitch, we've got everything from drones to GPR, and we're very keen to try and help our clients utilize different sensors and technologies together. But I think we're coming to the end of our time. It's been a really great discussion, and I'd like to thank Shirley, Kate, and Carl for joining me on this. Is there anything else any speakers would like to add on the subject of building surveying techniques that we haven't covered? Okay, no. All right. Well, I think it's been really fascinating. So thanks a lot for joining us on this. As Shirley mentioned, we've got some videos about GPR that can be viewed, and they're on our YouTube channel, which will also have this hour of fabulous content added to it as well. But for now, I'd like to thank Shirley Underwood, Kate Hint, and Carl Skelson for joining me, and I'd like to thank everyone else for tuning in. So have a great day, everyone, and
happy Easter also to everybody.
Happy Easter.
Absolutely, yeah.
Happy scanning.
Enjoy the 4-day weekend.
And happy scanning, yeah.
Yeah, right. We're nearly there. All right. Have a great Easter, everyone. Bye-bye.
Yes.
Thank
Bye-bye.
you.
Thanks, everyone. Bye-bye.